Okay, so I'm on your physical systems, Google Classroom. Under week 2, properties and phases of matter. Wednesday is density today. So hopefully you've gone through the reading and some problems, and it's probably been about 35 minutes on here. I also filmed a little 10-minute lab demo. It's kind of silly. You can just watch that if you're having issues understanding the concept of density. But we can calculate, because density is able to distinguish one property from another. On my selfie for this Flipgrid, I took a good picture, but then it blocks the picture with my name. So if you notice, there's one block on the bottom of the jar with water, and then there's one block that's floating. That's what that picture is, with a question mark. Go watch that and see, and comment on that as well. Just click reply, the little green clouds, quotation clouds, and you can film your response. Answer me any of the questions from within that video near the end about the grapes, about the honey, or about why one block floats and the other one sinks. For now, let's go straight to mass and volume. So I'm going to click on here and open with Kami. So I click on it, open with Kami, and here we go. So what you can pause this video to look at here is this: to solve density problems, 3 rules. List the given and unknown values, write the equation for density, and insert the known values into the equation and solve. So list the given and known values. Let's go ahead and do that first. I'm going to work through this problem as an example, okay? So let me put on my annotate here, and let's see if I get good handwriting or not on the computer. So the given in this problem is mass. And remember, mass, you don't have to write mass. I would probably write M, okay? So mass is equal to 9.17. You kind of have to go back to your metric system. Remember that grams is mass, it's weight. The other thing, that's what's given here. We also know the volume, which is, in this case, V. That's a big V. And the volume, they tell us, is 10 cubic centimeters. So if you did not know, I'm going to write it up here in the upper right corner, but 1 ml, that's a milliliter, is equal to 1 cubic centimeter. So if you can imagine, I'm going to draw it over here. So if you can imagine 1 centimeter by 1 centimeter, okay, that's a square, by 1 centimeter, that's a cube. So if the number here, I don't do cubes very good, is 1 by 1 by 1, 1 in width, 1 in height, and 1 in depth, okay? 1 wide, 1 high, 1 deep. And that would be a cubic, because 1 centimeter times 1 centimeter times 1 centimeter is 1 cubic centimeter, and that's the way we say that. 3 dimensions: length, width, and height, okay? All right, so you didn't need to know this all so much. I'm going to erase just this portion. If you want to see it or write it, you may. Just pause the video to do that. But right now I'm going to continue. So the formula for density, and let me make this a little bit thicker. The formula for density is D equals M over V. Okay, that's density is D, M is mass, V is volume. Okay, so number 2 was write the equation for density, and we did. List the given and unknown values. Whoops, we haven't written the unknown values yet. So let's go ahead and write the unknown values, and the unknown value, of course, that they want us to solve for is density. Sorry, density, come on, I'm just gonna say, and it's a big D, and we don't know what it is. That's the variable, it's called a variable. So an equation is usually there's an equal sign, and it's where one side will equal another. It's how to solve for some unknown. And right now, density is what we don't know. All right. Well, we have the knowns and unknowns. We have the formula. The third step is just to insert them. So density, we're going to leave as a big D because we don't know it. But mass we can plug in is 9.17 grams. It's a dot I'm trying to do. And divided by the volume, which in this case is 10.0. And again, you can put ml or cubic centimeters. Okay, you can put either one of those. So now you just get your calculator and you punch in. I don't have a calculator. I should have had that ready maybe. If you know how to use a calculator. So I got my calculator now. I'm putting 9.17 division sign 10 equal sign, and what you get is 0.917. And don't forget the units. Grams, and you do a per, we didn't get rid of them, per cubic centimeter. Okay, and this right here is the answer. So we did 1, 2, 3. We listed our knowns and unknowns. We wrote our formula, and then we plugged in what we knew into the formula or the equation to solve for the one part we don't know. The rest is basic arithmetic. I'll always give you the formula, so no stress here. So if you haven't already, write down these 3 steps in this example and do it in better handwriting than I did, because I am going to clear this now so we can do one on the Kami. I'll do one difficult one. Well, yeah. So I'm going to push clear now. Clear all drawings. And I'm going to now go to Kami. Okay, so here we are in Kami. I do not want to work numbers 1 and 2 because those are just like the example I used before. So identify the knowns. You have an 8 cubic centimeter block and you have a 12.9 grams. Okay, write your equation, which you should have up here. We should always be referring back to this equation, mass divided by volume. So that's step 1, step 2. You ought to write them down. I'm not writing them down for you. And then you just solve for this by dividing the mass, 12.9 grams, by the volume, 8 centimeters. And whatever that number is, it sometimes is a decimal, that's going to be your density. Same thing for number 2. Now 3 and 4 are a little different. Okay, now they're giving you the density, notice here, and the volume, or in the case of number 4, the mass. Well, how do you solve? It's the same formula. How do you solve for these? And so while I do want you to go through those 3 steps, what I'm going to tell you here is that, listen to my words and rewind if you need to, you can solve for mass by multiplying both sides of the density equation by volume. So if you have, in the case of number 3, the density, as we know, equals mass times volume. We want to know the mass, though. How do you do that? Well, if you multiply each side, I'm going to put a dot for the multiplication, by volume, then what you end up with is volume times density equals, and these cross out, right? It's like saying V over 1, actually, and becomes mass. And now you just plug in your volume and you plug in your density. And here you multiply the volume and the density, and that will give you the mass of the object. Okay? So you can go back through and watch that again if you need to. And I want to make room here for this one. Now, what if you need to, I did number 4 just then. Crap, sorry to confuse you. Okay, so I just had worked out number 4, how to solve for mass. Now for volume. You can solve for volume by dividing both sides of the equation shown above by density. So you can solve for volume by dividing both sides of the equation. So for doing that, once again, we start with density equals mass times volume. So now we have density, and we have mass. Look at number 4 here. So we need to plug into there, and we can plug into here, but we don't know what volume is. Well, if you divide both sides, all right, of the equation, and you want to get rid of, and if you're just wanting to solve for volume, if you divide m, well, there you go. The m's cross out, and you're left with volume alone. And volume equals density divided by mass. You plug in your mass and your density, and that gives you the volume. Okay, so when you're solving for mass, you're going to multiply, and when you're solving for volume, you're going to divide to get rid of the mass on the one side, and you're left with V equals D over M. Now, hopefully you're not freaking out. You're just learning how to rearrange a simple equation, and you can watch those steps. Granted, I did the mass with the volume and the volume with the mass. It's all there. So there is a way to remember this easier. To make it easy is a triangle. That triangle has mass, density, and volume. Okay, so think about being on, anytime a number or a letter is on top of another one, that's a division problem. And anytime they're side by side, that's a multiplication problem. So to solve for mass, m, it looks like I have to multiply density times volume. To solve for volume over here is to divide mass by density. And to solve for density over here on the left-hand side is to divide mass by volume, which is our original formula. So this little triangle hopefully helps you to remember these things right here. To solve for mass, that is, if you're given the density and volume, this is how you solve for mass. If you're given the mass and density, this is how you solve for volume. If you're given the mass and the volume, this is how you solve for density. Okay? So hopefully those little tips and tricks work and help as you go through this, but I still need to work one problem for you. And this is the next level. Are you ready? So you can now work through 1 through 4. And I'd like you to try 5, and many like this are after it, okay? I'm going to add a dimension to this. I'm going to switch my pen real quick to number 1 because I'm going to need thinner lines. So notice number 5. It tells you machine shop worker records the mass. So you have a mass that's given. Mass equals 176. If one side of the cube measures what? Okay, don't freak out. So they're not giving us the volume right off, but they're telling us the parameters. So it's a cube, which means a perfect square, measures 4 cm. So we're going to have to do 2 math problems here because we don't know the volume directly either, but we do know that we can solve. It's wanting to know the density. So D is what we're going to solve for. And we need to figure out the volume. If one side is 4 centimeters, you might have already figured this out. So 4 on one side, 4 on the other side, and 4 on the back side. It's a cube, so every side should be the same. So 4 times 4 times 4. All right, that's how you get the volume. The formula for volume is length times width times height. Okay, length times width times height. So 4 times 4 is 16, and 16 times 4 should be 64. I'll double check. 16 times 4 equals, yes, 64. So now we know the volume. It's 64, and again, cubic centimeters. All right, so keep that in place for the rest of these when they just give you a part. So number 6, they give you the milliliters and they give you the grams. Remember that 1 ml is equal to 1 cubic centimeter, so you don't need to change anything on number 6. Okay, write these things down. This is on videos. You can always rewind those portions. So now you just, if we're solving for density, what's our formula for density? Density is mass divided by volume. So density equals 176 divided by 64. Plug that into your calculator and you will have your grams per cubic centimeter, right? Just put the number right here. That's the answer. Okay, as you go down, this one gives you parameters. So 10 times 5 times 20 for number 7. That gives you the volume, and they already gave you the weight. So you're still just doing the regular density. Number 8, PVC plumbing pipe distance displaces 60 ml when placed in a container of water. So if it displaces 60 ml, that means it has a volume of 60. So nothing changes. They're just throwing you for a little whirl with information, but it's still 60 ml. If the pipe has a mass of 68 grams, what is the density? Same formula. They give you both the volume and the grams. Nothing different. Number 9, solid mass of 13, volume of, what is the density? That's no different. For this one, the mass is 120 when 50 in total. 50 grams. So all you'll have to do here is subtract the 50 grams from 120, right? Because this is just the cylinder alone when empty. 30 ml of water are added, and now it has a new mass. So to figure out the mass of the water alone, you just subtract 30 from 120. So what's 120 minus 30? 90. So now you have 90 grams of water. If the rock is added to the cylinder, the water level rises to 75 ml, and total mass is now 250. What's the density of the rock? Well, we got to do a little more figuring. If you want to skip that one, you can. And these are higher levels. So these, but they're not difficult. You can do them. A student performs an experiment, 3 unknown. They get these measurements, okay? A, B, and C fluids with these 3 masses and these 3 volumes. So get these 3 densities, and the one that's most dense, what happens to dense objects? They fall to the bottom, right? Less dense kind of come here, and then the least dense floats on top. So that's what they want you to do with this one. Okay, and this is pretty cool. You can see a lot of experiments in YouTube, and you can do it at home with oil and water, how they separate, because water is heavier. It's more dense than oil. So label those layers A, B, and C after you figure out the densities. So use your density skills to find the identity of the following mystery objects. So marble, quartz, and diamond have these densities. Copper, gold, and platinum have these densities. So now you have these 4 items. So while digging in the backyard, you find an old coin. Its mass is 26.7 grams. Sorry. And the volume is 3. Once you find the density, you compare up here, and we'll find out what that dime is made of, whether it's marble, diamond, quartz, copper, gold, or platinum. Okay. Same thing here with the ring. It gives you all the parameters. You figure out the densities, compare to your chart, and that's it. Okay. So a lot of density problems here. Do as many as you can, and please email if you have any questions.